All right, so welcome everybody. Today I'm going to present, the motivation regarding this talk is actually based on the quote from one of the Black Hat talk. And there's a very nice quote from Marcos Slaviero. And basically, there are more and more resources in the cloud, but the number of known attacks against AWS and other providers too is pretty low. So it is for sure that this number will increase in future. And I hope that after this presentation, you will start to discuss in your teams, in your companies, how are you going to mitigate those modern threats. But before that, let me introduce myself. So my name is Paweł Rzepa, and I work as a senior ethical hacker in SoftServe. I also recently started my career as AWS authorized instructor. So I'm giving the AWS courses. And after work, I'm still passionate about the cloud security. So some of my researches can be found on my Medium blog. If you are interested in some cloud security news, then I encourage you to follow me on my Twitter and LinkedIn accounts. All right, so most of the attacks start from initial access. What we already know. So before we will jump to the less obvious attacks, let's talk a little about commonly known methods. One of them is IAM keys leak, and it was the real plug in GitHub. So what I did recently the research. So I committed the real AWS keys in one of my GitHub repository, and in around 50 seconds, I got a notification email from AWS, and after around 6 minutes, I got first attempts to use those keys by malicious actors. Now, if you think that 6 minutes is a good time, then, well, I think it's pretty slow for bots, right? So there's an explanation why it took 6 minutes, why it took so long. First of all, this situation has changed a little recently. So once I got the email notification from AWS, I automatically, to my compromised keys, there was added the AWS compromised key quarantine. And this policy actually denies some dangerous actions. Of course, not all of them, but definitely that's a good step by AWS. Furthermore, a few days later, I got a notification, I got a notification about the created support ticket for this incident. And I got quite interesting information from AWS support that, hey, I'm running 3 instances launched in one of the region, which actually that was true. When I searched the event history of the CloudTrail, I seen nothing. But in CloudTrail logs, if you want to read CloudTrail logs in CLI, then this is this is not trivial. But once I filter the actions taken by AWS support team, you can see that they can, investigate the issue and help you. Now, why those bots were so slow? This is because GitHub implemented the mechanism of finding those leaks. So, for example, AWS keys. Of course, not only AWS keys, but including them. Before they will publish the latest commit in public repository, they are delaying it by 5 minutes. What it means, you have 5 minutes for your reaction to block those keys and to take some actions. After those 5 minutes, this is accessible for publicly, and of course, malicious bots then will start harvesting your keys. This is a well-known method. Another well-known method is compromising the web application, and because of which is hosted in the cloud, and then exploiting the vulnerability like server-side request forgery, remote code execution, or unintended proxy, because then you can go and grab the instance profile that is attached to this particular instance, to your web server, and then you can escalate your attacks. If that is something new to you, you don't know much about it, then I encourage you to go and watch my previous presentation about it. If you want to read more about the real case scenario, then I think the Capital One breach is a great example here. What is new regarding compromising the hosts in the cloud is that the new group, well, they are not new, but they started their campaign in 2020. The Team TNT group, they are targeting many applications, mostly Kubernetes clusters. So they are searching for Kubernetes clusters which have publicly accessible control panel, and then they are start harvesting AWS credentials, and probably in future they will do more about lateral movements and privilege escalations, and to make even better results. If you are curious about the Team TNT operations, there's a good research about it. So encourage you to go and read all of it. But now we are going to the main part of this presentation. What if I don't have any publicly exposed resources? I don't use any IAM users, which is pretty common nowadays. People stopped using IAM users, and instead they are using the IAM roles. And it is not a rare thing that people started scanning their cloud infrastructure against any misconfigurations. Well, obviously, this still can be hacked. First rule, do not trust people in the cyber world. I think we all fail. And let me prove it. In the previous year, I made a little research, and I needed a Lambda function that was responsible for renaming the names of the files uploaded to the S3 bucket. So once the file is uploaded to the bucket, then the event is triggered. The event triggers Lambda function, and this Lambda function should rename the name of the file from test new PNG to scan me test new PNG. I haven't found ready to use library, so I created my own package in npm.js repository, and I called it S3 object rename. I put some usage instructions, and that's pretty easy to follow package. What you can see after a few days, after several days, there was 53 weekly downloads, but after a month, there was almost 500 downloads of this package. What is so special about it? Well, I created, so here, just to give you the idea, the concept of this package. So here, if you use it in the Lambda function, you have to attach it to your Lambda function. And then you have to just run, you have to give the name of the bucket, the name of the file that you want to rename, and the new name of the file. Pretty easy, right? So when you run it, then you will see in your logs that everything went smoothly, everything is good. So that's all. But under the hood, if you investigate this S3 rename package, you will see a line of obfuscated JavaScript code. After this code is basically doing this thing. So it verifies if among the environment variables, if there is the AWS access key ID. So it doesn't have to be run in Lambda function, but if it is run on your local workstation and you have configured AWS access key ID in your environment variables, then this obfuscated code will be launched. And what it does, well, it basically sent as the get parameter to my server, and I got those AWS key on my server. What is pretty scary about it is the fact that I got not only my test AWS access keys, but I also get keys from random users who were blindly running my package. This is not new attack technique. Actually, there is even better attack technique, which is called Typosquatting. In 2016, one researcher made pretty good research. So what he did, he uploaded a lot of renamed packages, which names are very similar to the original packages, like coffee, but with just one letter E. And he uploaded it to the Python package, the Ruby package, and the JavaScript packages. The results were, again, very scaring, because there were more than 17,000 of unique hosts where these packages were launched. Basically, he was testing the launching similarly to me, that he was grabbing a notification request taken from the victim. Now, the new thing that appeared recently was that one of the developer, he published a package which is named as a dash. And this package that didn't contain, well, I'm not sure if it is now it is accessible, but there was no malicious code inside. However, he was testing if he can name package like that, like a dash or double dash. And there was almost, there was over 70 hundreds, thousands of downloads. Why? Well, probably because if you put such name, such comment in your CLI, like npm I dash spacebar, some flag, some package name, then it will install this this package named as a dash. Going even a step further, also a research from this year regarding the supply chain attack, I'm sorry. What was about the researcher found in the internet, in the publicly accessible resources, a lot of packages, a lot of internal packages, packages which were used by Apple, Microsoft, and other big companies. Now, those internal packages were only accessible in their internal repositories. Okay, but he found a way that there are those package managers used commonly in those companies by developers. They can, for example, if this package is not accessible anymore in the internal repository, then this package will be downloaded from the publicly from the public repository. Or if there is a newer version of the same package name as it is in the public repository, it will be downloaded. So in this way, the researcher was able to run remote code execution in big companies. Now, going into the cloud, is the package, the supply chain attacks only accessible, only a threat against packages? Well, not only. So here's an example of community AMI. When you are running the EC2 instance, you may choose the brand new Amazon AMIs, or you can take some Amazon machine images from the AWS marketplace. So for example, I was searching for Apache Guacamole. So in the AWS marketplace, you can find the AWS EC2 instance with pre-installed and pre-configured Apache Guacamole, which is super nice feature, because without all those configuration steps, I can just in a few clicks, I can spin up the EC2 instance with working Apache Guacamole server. But there is also a community AMI. Everyone can also publish the community AMI with the same thing. So for example, I can create my own AMI and publish it with the working Apache Guacamole. The difference is that those from AWS Marketplace costs additional money, and community AMI are for free. Those in AWS Marketplace, they are scammed. This price always, you have always something for this additional price, because it goes from the authorized sources, as well as those AMIs are scanned by Amazon. But those in community AMIs are not. And this is not a rare observation, that some of them are already infected. Here is the example that the one company, they discovered after 5 years of running this AMI. They found that this EC2 instance is quite slow comparing to others. So they started investigating it, and they found that this AMI is actually infected. So they reported it to Amazon. Of course, it was removed. But the thing is, how many of you is using those from those community AMIs, and they are really investigating if there is any malware inside of them? Because there can be any kind of code that is running on your cloud resource. Another thing, the serverless application repository. Another great feature, great service in AWS, that you can publish your serverless application, and it can be run by others. And I was searching for serverless Goat. If you don't know this project, definitely go in the GitHub page and find more about this serverless Goat. one important thing is that this repository is no longer maintained. What it means, it was created that this is the original deployment in serverless application repository. However, the node runtime version is deprecated in this version, what means it doesn't work. So there are other alternative versions, like with the same description, with different names, with different number of deployments. And even in the GitHub issues of serverless Go, you can find that the advice just go to serverless application repository and search for AppSec serverless Go, because there is a fix and it is the working version. So, but what are those? Well, nobody knows. They are deployed and they are released by other AWS accounts. So there's no problem if I'm going to release another serverless Go version with even cooler name, like this is the latest serverless Go, and people are blindly running it. I hope that all of you are reading the code before running it, but the practice shows that, well, not all of us. Another interesting fact is that we are giving this access to our cloud resources, and it is pretty often, and it is only visible in the trust policy. So you have a role that, and this is your AWS account ID, and this is the AWS account of this third-party service. Okay, so for example, this third-party service is doing the log monitoring for you, so they need access to your cloud account, and most often it is done by adding access via the IAM role. Now, there was another research that 82% of companies unknowingly give third parties access to all their cloud data. Now, why unknowingly? Why so many? And why access to all cloud data? Because that is the easier way. Okay, so here's the instruction from one third-party service, pretty common, that I've seen a lot in the wild, and they are giving the instruction that, hey, give us a read-only access role, so we will be able to do our job. Now, read-only access, and it is very common that those third-party services are asking for such role. Why? Because, as you remember, a free bucket name has to be unique. Okay, so every AWS account which has the buckets for logs have to be named differently, and it should be the access. For example, this third-party service require access only to one bucket and only permissions to read objects inside of these buckets with logs, but it is much easier to ask for read-only access. But it also gives an access to all the, the read access to all other services. Now, when I went through this research, my first thought was, hey, is the cloud version of SolarWinds is just a matter of time? Please let me know in comments what do you think about it, because I think that sooner or later one of those third-party service will be compromised and that gives access to hundreds or thousands of AWS accounts which are using this third-party service. So as you see, initial access is possible even if you are not exposing any vulnerable resources in the public internet. Now, let's go through the privilege escalation methods. Pretty known, I hope that it is commonly known among you, methods of escalating privileges. This method is based on the research of Spencer Gitson. And basically, it searches through the dangerous permissions. For example, if compromised principal, it can be the IAM role, it can be the IAM user. If this principal has the permission to pass role and to EC2 run instance, then this user can simply spin up a new EC2 instance, and with attached instance profile with the admin role. And in this way, then accessing this instance will give the access to the admin role, which gives you access to all resources in your account. But this is about the lesser known techniques. So here is my research. It is based on some misconceptions in trust policy, because basically, in general, IAM role, every identity and access management role can be assumed when those two requirements are satisfied. So first of all, there has to be a trust relationship with the principal. So for example, my compromised AWS identity and access management user has to have the trust relationship with this particular role. And it should have also this STS assume role permission. I've seen several times when there was approach that, for example, operators in AWS account, they didn't have the assume role permission, and only administrators have this permission. And in this approach, every administrator can assume any role in this account, which is good because operator cannot assume this role, right? So there's no way about the privilege escalation. Well, this is not always true, because I found some ways that this requirement doesn't have to be satisfied. And here's the example. When you have the trust policy, which has this organization ID, okay, so nowadays, I think that everybody, well, surely not everybody, but most of working companies in AWS, they use AWS organization. And it is much easier to configure such role for all principals in the organization. So there's a wildcard, but there's also the condition. So the accounts which are external to this organization cannot assume this role. But what I discovered, it was that if there is the wildcard here, and no matter what condition is there, any principal will be granted with the STS assume role permission. In other words, the trust policy behave like resource-based policy, so it can grant permission to the principal. And you don't then require the assume role permission. In the when you search for trust policy, some references in the official resources, like for example AWS security blog, which is awesome, by the way, You can find that such policy is even in this blog as a reference. Now, as you can see, I'm referring to this article using the web archive, because after publishing my article, this section was removed, which is awesome because now I have a proof that AWS folks, they are listening, they are they see the researchers' work, and they are trying to do better. This is not the only way how can we bypass this requirement of having the assume role. Another very interesting, which is still quite old for me, thing about trust policy is that if you put in the principal role ARN, sorry, of the role, then this role again doesn't require the assume role permission, which is weird. In this case, just imagine that there's a compromised, unprivileged IAM user, which then is allowed without assume role permission, is allowed to access the maintenance role. And then if the admin's role trust policy have this principle, have this role in principle, then from the maintenance role, it is possible to access admin role. That may be quite confusing and hard to understand. So let me show it on a demo. So here I have compromised user. Okay, as you can see, there's no permissions. So this user has no permissions. Okay, so nobody cares about compromised user which has no permissions. We have this maintenance role with read-only access. So again, nothing very scary, just read-only access. And if we go to the trust relationship, we can see that, yeah, there is wildcard in the principal, but there is also condition that only principal from this AWS account can, this AWS organization can assume it. So assuming I have this compromised account long-term keys, so here using the AWS SDS get caller identity, here I can prove that yes, I'm using this compromised user profile. So now let's try to assume the maintenance role. You can do it by the command SDS assume role, then you have to specify the ARN name of the role, and then voila, you are getting the AWS access key, secret access key, as well as the session token, because roles do not use the long-term credentials. So let me now configure this maintenance role profile on my local workstation. Here I'm specifying the AWS access key ID, secret access key, as well as the region. And I have to also specify the session token. And from the CLI, you can do it by AWS configure set AWS session token command, and then you are specifying the session token. So let me just quickly copy paste it. And then, of course, in the name of the maintenance role profile. Okay, so that gives me, so let's now check if this role was configured properly. So again, SDS get caller identity, but this time using the profile maintenance role. And it is a confirmation that, yeah, I'm using the assumed role maintenance role. Now, there is another role under the same account, but this time there's no wildcard in trust policy. So let me check the trust policy of the admin role. Okay, there's an administrator access attached to this role. But this time, instead of wildcard, there is the maintenance role, which is allowed to assume the admin role. So now, because I have this my maintenance role, I can assume my admin role too, okay? And as you can see, now I am the admin role. So always, if you are doing some pen test stuff, remember to verify those trust policy configurations. Good. Now, regarding data exfiltration, it is well known that you can, once you are inside, you can exfiltrate data using numerous ways. Like, for example, you can do a shadow copy of the EC2 or RDS snapshots, and you can then share it with the attacker's AWS account. You can, if you have permissions to the simple email service or simple notification service, then you can simply use them to exfiltrate those data. There is even the VPC endpoint way that you can set up the connection from the restricted VPC to particular services like S3, for example. So imagine that you have restricted VPC, and so there is no connection, outbound connection to the internet, so you cannot use S3 service. But if you set up the VPC endpoint, then from this restricted VPC, you can access the S3 service, not going out from the Amazon infrastructure. But the thing is that all of them can be monitored. You will see logs when you investigate the issue. You will see all those logs or when the attacker used those services. So lesser known, okay. Just the lag, sorry. So in lesser known technique is the DNS exfiltration, which is so cool for me. There is default configuration. When you are spinning up the new VPC or you are using the default VPC, there is always by default enabled DNS resolution. What means that once you spin up your EC2 instance in the VPC, then you don't have to worry about the DNS, because when you type, for example, curl google.com, then you will get the name google.com will be resolved by the Amazon provided DNS. Easy, right? But the devil is in the details. And if you go through in detail through the Amazon documentation, you will see that this DNS traffic actually cannot be controlled. In other words, you cannot block it, control it using the network access control list or security groups. Furthermore, there is the VPC flow logs. If you are familiar with this, this is the service which is responsible for logging all the network traffic. Okay, like what was the query, from which source IP to which destination IP, what protocol, and so on. However, even in the documentation, there is the clear statement that this DNS traffic, the traffic to Amazon DNS server, is not logged at all. So what it means from the attacker's perspective? Well, it is a great way to exfiltrate data which is silent. They exfiltrate data because it is not logged anywhere. So imagine the following situation. I have the private subnet and I have the public subnet. From the private subnet, every traffic which is going outside of my subnet should go through the public subnet to the internet gateway and then to the internet. But knowing that the Amazon AWS provided DNS infrastructure is using the different infrastructure, when you do the following command like ping, and here is the secret message encoded in base64, then I'm the owner of the name server rzepski.com. Now, this query will be then sent to my DNS name server, which is the rzepski.com, and then I can see this secret message. Of course, I can go a step further, and instead of just sending the secret message using the DNS, I can set up a reverse shell, right? So imagine you have the restricted VPC, and you can spin up the reverse shell over the DNS. Okay, so this instance shouldn't have access with the internet, but I can run the DNS cat2 binary on it. Okay, and then it will connect to my name server. So using the DNS traffic, it will give me the reverse shell to this victim instance. One important thing to note is that this is very loud. Okay, so there's a lot of DNS queries when you are setting up the reverse shell. And if you are so loud, then there's a good news for you, because it will be detected by the AWS guard duty. So then you will get the incident that there's a possible DNS data exfiltration. So what about defense? Let's start from the ending. So regarding the DNS exfiltration, there is a new service which is called the Route 53 Resolver DNS Firewall. And this service was released at the end of March of this year. So that's pretty new. And from my experience, it seems that it is not commonly used. So in other words, I don't know any customer which uses the Route 53 Resolver DNS Firewall, but it is definitely something that you should use. Why? Because then you can see any logs. You have the ability to allow, block, or alert any DNS queries. And for example, here I specified all the domains, and I want to be alerted about all DNS queries, and then in the logs I can see them. And then once you test it, you can then specify the allow or block rules. Regarding the privilege escalation, start from limiting permissions to third parties. Seriously, this is very common and practice, what I've seen among my customers. So it was even that I asked, hey, why they have so much wide permissions, and all of them replied that, hey, this is how it works. The third-party service is asking directly for these read-only permissions. There was also a situation when I found some AWS account which has even higher than just read-only permissions, and it took several days for the customer to investigate who the hell is this AWS account? And after several days of investigation, they found that, well, this is the third-party service which we were using a couple of years ago, and we no longer use it. But well, they forgot about removing it from the trust policies. And another great service that you may like is the IAM Access Analyzer. And based on the history of usage, IAM permissions, all AWS permissions, it will give you an information which permissions are used by every principal and which are not and can be removed. So this is a great approach to set up the least privilege policy. And one more thing, if you are doing security assessment, it is not just running a scanner. Finding just misconfigurations of the service is one thing, but do not be so focused on just finding the misconfigurations, because if you run a scanner, it will not detect those issues. Well, vast majority of scanners will not detect the issues in trust policy, because from the perspective of scanner, it looks like legitimate traffic, okay? And regarding the supply chain attacks, well, that may sound quite sarcastic, but use only trusted resources. Now, I need to say why I need to explain myself why I didn't use, more instructions what should be done, because it depends on how you use AWS, how you use any cloud, and how your infrastructure look like. So for example, one good rule is to use the golden AMI image. Okay, so you have the authorized brand new AMI from Amazon, which is free from any malware. And then you are baking it in with all the dependencies your application require, with all software additional and so on. And your users are allowed only to use this golden image. And this is in general a great rule. But if you don't maintain this golden image, then it can very quickly become, unpatched and vulnerable to newly discovered vulnerabilities. So yeah, so forgive me, but regarding this class of attack, I have to just say that use only trusted resources. Raise awareness among your teammates that such attacks are possible, and those attacks, I'm pretty sure they will be more and more often visible in the wild. All right, that's all from my side. So we are a little after the time. So if you want to connect, I would really love your feedback regarding the presentation. This is the first time I was giving this presentation, so I would really appreciate any feedback from you. Again, if you want to follow me on Twitter or LinkedIn, feel free. There I'm sharing my latest findings. Okay, that's all from my side. Are there any questions?